Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. Today, we're diving deep into a fascinating topic, MemOS, a memory operating system for AI systems. I'm really excited about this one.
Me too. It's about time we started looking beyond just throwing more data at the problem. Memory is clearly a critical component of intelligence, and it's been frankly underappreciated in the current deep learning craze. It's nice to see this come to light.
I'm cautiously optimistic. I agree that memory is crucial, but I'm not convinced that simply bolting a better memory system onto existing deep learning architectures is going to magically solve the AGI problem. We need structure. We need representation.
Exactly. It's about structure, and especially about spatiotemporal structure. Current deep learning is just brute force pattern matching. I think MemOS has a lot of potential to address the spatial temporal issues, though.
All right, let's unpack this a bit. For our listeners who might not be totally up to speed, when we talk about MemOS, we're essentially talking about designing an operating system specifically tailored for managing memory in AI systems. Not just storing data, but organizing it, retrieving it efficiently, and most importantly, understanding the relationships between different pieces of information.
Right, think of it like this. Your computer has RAM and a hard drive. It's not just a big pile of ones and zeros. The operating system knows where everything is, how it relates to other files, when it was last accessed. That's what we need for AI. We need AI to have an OS that is as good as ours, if not better, at managing information.
Yes, and the key difference is that our OS isn't just storing data. It's also managing relationships between data in a way that allows us to reason. A simple lookup table isn't enough. For example, a car is a vehicle, and a vehicle needs fuel. The AI needs to learn these types of relationships.
And those relationships exist in space and time. A car moves through space over time. Understanding that spatiotemporal context is what allows us to predict its behavior, to plan routes, and to react to unexpected events. Any AI model should have an understanding of that. Current models are just bad at understanding it.
Okay, so let's say we're trying to build an AI that can navigate a self-driving car. A conventional deep learning system might be trained on millions of images and LiDAR scans to recognize traffic lights, pedestrians, and lane markings, but it often struggles in novel situations, like a detour with confusing signage. A MemOS-powered system, on the other hand, could theoretically represent the road network as a graph, understand the rules of the road as symbolic constraints, and use its memory system to recall past experiences in similar situations to make better decisions.
Exactly. And that's where the potential for AGI comes in. If we can build AI systems that can not only recognize patterns but also reason about them, that can build up a world model in their memory and use that to make predictions, we're getting much closer to a truly general intelligence.
But how do you get that symbolic representation into the system? That's the million-dollar question. Deep learning excels at learning patterns from data, but it's notoriously bad at representing abstract concepts or logical rules. The car example is good, but I see real-world issues on how the symbolic model could be built on top of that.
That's where the spatiotemporal aspect becomes crucial. Imagine representing the world as a series of nested coordinate systems. You have the car's local coordinate system, the road's coordinate system, the city's coordinate system, and so on. The AI needs to be able to seamlessly translate between these different frames of reference to understand its place in the world.
That's a great point. It connects directly to my own thinking about this. I've been wondering about the neural correlates of consciousness and how we can incorporate those concepts into MemOS. If we could pinpoint how the brain organizes and retrieves memories, especially episodic memories linked to specific times and places, we could potentially create memory systems that not only store information, but also experience and understand its significance.
That's fascinating. You're talking about imbuing AI with a sense of self, a sense of its own history. That would be a game changer. It could lead to AI systems that are not just intelligent, but also wise, learning from their mistakes and adapting to new situations in a much more human-like way.
But how do you define experience in a way that a machine can understand? Is it just a matter of tagging memories with emotional labels, or is there something more fundamental going on that we're missing? I think we should incorporate a more modular architecture for the AI system. Deep learning for some parts and symbolic models for others. That way we can leverage the benefits of both systems.
It's not just emotional labels, but context. The experience is embedded in a rich network of spatiotemporal relationships. It's about where you were, who you were with, what you were doing, and how those factors influenced your state of mind. Current deep learning algorithms miss almost all of that. They only capture the statistical significance of some arbitrary relationships.
So let's take a practical example. Imagine an AI system designed to assist doctors in diagnosing diseases. Right now, these systems primarily rely on pattern recognition, identifying correlations between symptoms and diagnoses based on vast data sets. With a MemOS style system, the AI could potentially build a more comprehensive model of each patient, incorporating their medical history, lifestyle, genetic predispositions, and even environmental factors. It could then use this model to reason about the patient's condition, generate hypotheses, and suggest personalized treatment plans, all within a spatiotemporal context of the patient's life.
And the beauty of it is that the system would continually learn and refine its knowledge base over time. As it encounters new patients and new cases, it would update its internal model of the world, becoming more accurate and more reliable in its diagnoses. That's the power of a truly intelligent memory system.
But that also raises some serious ethical concerns. If the AI is making decisions based on a patient's lifestyle or genetic predispositions, how do we ensure that it's not perpetuating existing biases or discriminating against certain groups? The AI should not be discriminating people. That would not be safe at all.
Exactly. The spatiotemporal context can be a double-edged sword. It can provide valuable insights, but it can also reinforce harmful stereotypes if not handled carefully. You need a system that understands the limitations of its knowledge and can identify potential sources of bias.
That's where the AI safety aspect comes in. If AI is to reach human levels of intelligence, it is crucial to have that safety built in. And actually, this discussion brings me back to something I've been pondering lately. I saw an article that Amazon is pursuing a neuroscientific approach to AI safety, which is a very interesting direction. It suggests that they might be moving away from pure deep learning and towards more biologically inspired algorithms.
That's fascinating, and it makes sense. If we want to build AI systems that are safe and reliable, we need to understand how the brain achieves those qualities. The brain has evolved over millions of years to be incredibly robust and adaptable. If we can reverse engineer some of those principles, we can build AI that is less prone to errors and unintended consequences. I think Amazon is right on track.
I'm still skeptical. I think focusing on neuro-symbolic AI is more likely to lead to robust and controllable AI systems. I wonder if Amazon's AI safety research plan includes neuro-symbolic approaches or is mostly focused on mitigating the problems of deep learning systems. It's like, are they trying to make a fundamentally flawed system safe? Or are they trying to build a fundamentally good system?
The problem is, how do you scale up neuro-symbolic AI to handle the complexity of the real world? Symbolic reasoning is great for well-defined domains, but it often struggles with the messy, ambiguous data that we encounter in everyday life. The system should be able to translate to different coordinate systems. That would be a great start. It needs to be a hybrid approach that combines the strengths of both deep learning and symbolic reasoning.
Yes, a hybrid approach. It's about finding the right balance between pattern recognition and symbolic reasoning. Deep learning can be used to extract features from raw data, while symbolic reasoning can be used to build more abstract models and make inferences. Maybe this is what Amazon is working on.
I agree, and I think the focus on memory is a crucial step in that direction. If we can build AI systems that can efficiently store and retrieve information, that can learn from their past experiences, we're well on our way to AGI. MemOS could be the key to unlocking that potential. It would also force a shift in the architecture of deep learning models. We might need a radical shift, and that would be great.
I still believe that the key to true intelligence lies in explicit knowledge representation and reasoning. That the current emphasis on massive datasets and complex neural networks feels like a brute force approach to intelligence and not a true understanding. It feels like building a car by using a million parts. You might get something that moves, but it won't be a car.
And the sheer computational cost of deep learning methods often makes them impractical for more sophisticated reasoning. If MemOS fails to incorporate clever spatiotemporal frameworks from the ground up, a brute force approach will result in an untenable model.
Okay, so let's shift gears a bit and talk about future research directions. From my perspective, I'm really interested in exploring how we can integrate our understanding of the brain's memory systems into the design of MemOS. I want to understand how the hierarchical organization of the brain, with its different cortical layers and interconnections, can be reflected in the architecture of MemOS. Could we create a system that learns more effectively by mimicking those structures?
From my point of view, the most pressing research question is how to scale up MemOS to handle truly massive datasets. The sheer volume of data required for deep learning models is astounding. How can we efficiently process and retain all of that information without overwhelming the system? I think scaling this up will unlock more potential for complex and intelligent AI.
I think we need to focus on developing better neuro-symbolic algorithms. How can we seamlessly integrate symbolic reasoning with deep learning? How can we ensure that the knowledge represented in the system is accurate, consistent, and free from bias? Those are critical questions that need to be addressed.
I think the holy grail for AI isn't just about more data or more powerful processors. It might be about understanding how different coordinate systems, physical, abstract, etc., interact and how to build an AI that can seamlessly translate between them. I want to explore how different coordinate systems, for example, Cartesian, polar, temporal, are represented and transformed within the MemOS architecture. If the core algorithm can't seamlessly translate between them, it will struggle to reason about complex spatiotemporal relationships.
Those are all fantastic points, and it highlights just how much work there is to be done in this area. But I think MemOS represents a really exciting step forward. It's a recognition that memory is not just a passive storage medium, but an active and integral part of intelligence. And that's something we should all be excited about.
Absolutely. It's a paradigm shift. It could bring AGI closer to reality. Instead of just scaling systems, it's about improving what the system already has.
I agree that it's a step in the right direction, but we need to be mindful of the limitations of current approaches. We need to make sure that we're building truly intelligent systems, not just clever pattern recognition machines.
And we need to keep the spatiotemporal context in mind. That's what separates true understanding from simple association.
Well, that brings us to the end of our discussion for today. Thank you all for your insightful contributions. And thank you to our listeners for joining us on this cognitive spiral. We'll be back next week with another deep dive into the fascinating world of AI and neuroscience.